Welcome children. Now today electrostatics for class 12. Few topics I am going to discuss with the children, and these are very important topics. Fundamentally it is used for NET and DIPOLE exam. So one by one I am discussing. First, what is first I shall introduce flux. Already I have told you, if flux phi is given by E dot ds, that means these are the topics you write down: proof of Gauss's law, Coulomb's law from Gauss's law, electric field for charged spherical shell using Gauss's law, and dipole, potential energy, torque for dipole. Now first I shall introduce flux. So when electric field is given in terms of vector form and area is given in vector form, then you take the dot product to get the flux defined. Now according to Gauss's law, we know total flux through any closed surface, Gaussian surface, that is Gaussian surface, total flux taking integration E dot ds, total flux equal to charged enclosed, that means inside charge, by epsilon naught. That is the mathematical form of Gauss's law. Total flux through any Gaussian surface equal to total charge enclosed by the surface epsilon naught. This is the basic fundamental law of Gauss's. Already I have discussed in my different lectures. Now I shall prove this law. Proof of this law, what will you do? You take a arbitrary surface. Suppose you are taking a surface, you are taking a charge Q. Now this is the surface. You take a point P and you consider a surface ds. Clear? So this ds at the point P, this surface, electric field E at the surface, E at surface, you know, how can you write? That is a Q by 4 pi epsilon naught by r square. So in that case E dot ds, total E dot ds equal to, you are getting, you put the value of E, that is a Q by 4 pi epsilon naught r square into ds cos theta. Now it is better for you, that means you can write, if you take total flux E dot ds, then you are getting integrate Q 4 pi epsilon naught and you are getting integrate ds cos theta by r square. That is solid angle produced by the surface at the point O where charge is placed. This is the solid angle, that is solid angle d omega into Q by 4 pi epsilon naught. Now you know total solid angle, if you consider all surface on the total, the Gaussian surface was considered, then integrate total solid angle equal to 4 pi. We know. So d omega equal to 4 pi. So you are getting 4 pi into Q 4 pi epsilon naught. 4 pi cancel, Q by epsilon naught. That means we are getting total flux equal to Q by epsilon naught. In this way you can derive in exam, CBSE board NCERT exam, plus 3 marks may come for deduction of this formula. So first to consider Gaussian surface, there is a charge Q, consider a surface, elementary surface on the Gaussian surface ds. This ds makes solid angle d omega at the point Q. D omega they produced. Now E dot ds, you are getting Q by 4 pi epsilon naught. Q E dot ds means E you are getting, instead of E you are getting the ds cos theta. So integration ds cos theta by r square equal to d omega, that is the solid angle. Total solid angle, if you consider throughout the Gaussian surface, total solid angle coming 4 pi. Now 4 pi cancel, then q by epsilon naught, q by epsilon naught. So this is the proved Gaussian law I have told you that, and I have proved the Gaussian theorem. Always remember that if this charge, another charge is outside, so total flux through the Gaussian surface not enclosed, so it will be 0. That means outside charge don't consider for Gaussian theorem calculation. Now I shall derive the second one. First case I have derived, now I am deriving second one. You write down, all of you write down, open your book and you write down Coulomb's law. Suppose there is a charge q. Suppose there is a charge q at a distance r, at the point P, at a distance r, you draw a Gaussian surface. If you draw Gaussian surface, then at the point P, what are you getting? E dot ds integrate equal to total charge q by epsilon naught, already I know. Now if you consider all ds, that means total area of the spherical surface I am getting E, total area if you consider 4 pi r square, you are getting q by 4 pi epsilon naught. So at the point P, E, you are getting q by 4 pi epsilon naught r square. Again I am telling you, E already have derived. If you put a charge q1, then force equal to q1 into E, that is equal to q into q1 4 pi epsilon naught r square. This is the Coulomb's law. Already Coulomb's law you know. So first there is a charge q at a distance P, calculate electric field with the help of drawing Gaussian surface of radius r. What are you getting? Total surface area E dot ds, that means why in that case E and ds angle between them is 0 degree, so it will be, you are getting at the point it is 0 degree, that is cos 0 degree. So you are getting cos 0 degree because positive charge all flux in the same direction. So E 4 pi r square q by epsilon naught. So electric field at the point P is given by q by 4 pi epsilon r square. Now my question is that if you put another charge q1, total force on the q1 is electric field at the point and q1. So q into q1 4 pi epsilon r square, that is the Coulomb's law. Because you know Coulomb's law is given by the following formula when two charges, suppose here q and q1, distance is r, then Coulomb force is given q1 and q 4 pi epsilon r square. So I have proved this Coulomb's law with the help of Gaussian surface and Gauss's theorem. So it is proved. It is also in your exam, it may come 3 marks. So Coulomb's law from Gauss's law already derived for you. Now I am going to derive Gauss's theorem for charged spherical hollow sphere. I am deriving, it is clear that I am going to clear what I am going to derive now. You see, find out electric field, find out E electric field for hollow charged sphere. First, there is a charge at the Q. You consider a hollow sphere. Now there is a charge Q on hollow sphere. So if it is a charge plus all charge hollow sphere, charge residing on the surface, charge on surface. Now from the center O, consider different points P, another point Q, another point R. I am consider different points and you draw different Gaussian surface. Through P you draw Gaussian surface of radius R. So you are drawing spherical Gaussian surface like this. Okay, now if you consider Gaussian theorem, integration E dot ds equal to total charge, that is the charge of the sphere, because this whole charge is inside the Gaussian surface. So we have Q by epsilon naught. So we have E 4 pi r square Q by epsilon naught. So it will be E at the point P will be Q by 4 pi epsilon naught r square. That is the electric field at the point P. In that case, it is clear as if the whole sphere charge is concentrated at the center of the sphere. So at that case, formula will be EP equal to Q by 4 pi epsilon r square. Clear? Now if we consider Q point, then this formula will be EQ equal to Q by 4 pi epsilon naught r square. At the surface, electric field is given by Q by 4 pi epsilon r square, because in that case small r equal to capital R. Clear? Now I shall consider the Gaussian surface just inside the spherical shell. Now what is the electric field? Electric field just at the point inside there you consider as another consider Gaussian surface just inside. Then according to Gauss's theorem, you consider E dot ds equal to 0 by epsilon naught. Now whatever the surface, Gaussian surface area may be, E equal to 0. Inside electric field is 0. E is 0 inside, electric field is 0. It is maybe revision, because since 12 is very important, some lectures we are giving you revision lessons. E equals 0. So for a charged hollow sphere, it is clear we have considered electric field at 3 different points P, Q and R. Inside electric field is 0, so no lines of force is there, but remember V not equal to 0, V will be Q by 4 pi epsilon naught into R. So inside, if you consider different concentric spherical cell, their equipotential means at every point potential is same. Okay, now I should consider dipole. You know, for dipole we are considering 2 lectures. I am starting dipole today. You know, there are some polar molecules and there are non-polar molecules. HCl, oxygen is a non-polar, HCl is a polar, where the 2 atoms define electronegativity, electropositive elements, positive charge, and electric negativity element, negative charge, both are separated by small distance, permanent dipole moment. So what is the dipole? Two equal and opposite charge separated by very small distance, the dipole moment equal to q into 2l. Direction is negative to positive. So I am telling you what is dipole. What is dipole? I have told you what is dipole. So there are some chemical formula or some molecules which having permanent dipole moment, those are polar molecules, HCl example. So two equal and opposite charge separated by very small distance constitute a dipole, and for dipole we have to calculate electric field and potential. Next class we must do it. Now we see that is the dipole. Now if dipole, we are calculating potential energy for I am calculating torque for dipole. Torque for dipole. Now a dipole placed in plus charge, this is minus charge, that is a 2L. This dipole placed in electric field E. Now two forces will act. For positive charge it will be QE, and for negative charge that is minus QE. So it is clear that two equal and opposite force acting on the dipole. Net force F equal to plus QE minus QE, that is equal to 0. So as a result dipole will not experience any accelerated rectilinear motion. So no linear motion, accelerated linear motion. No accelerated linear motion. But since on the dipole two equal and opposite forces acting, there will be torque. Now torque or moment of dipole, what will do? Force and distance, perpendicular distance between them, that is again x. So torque equal to any force into x. Clear? Torque will any force, and that is a plus q, that is the force will be along the direction of electric field. For minus q, electric field opposite, so q into x. Now from figure, so this is x on the electric field, this is x, this is the x, there is electric field directions, and perpendicular distance between the two force line, this is one line and this is another line, so this is the perpendicular distance. So x by 2l equal to sin theta. So you are getting torque equal to QE 2L sin theta. Q into 2L, already I have told Q into 2L dipole moment, direction negative to positive. So you are getting P vector E vector sin theta, or you can write P dot E cross E, or the dipole torque experience P cross E. That means if P is in vector form, E is in vector form, then to find out the torque, what will you do? You take the cross product. Already class 11 you have learned. Now what is the role of the dipole torque? This torque will align the dipole along the direction of field. Torque will align the dipole, along the field. Clear? Torque will align the dipole along the field. Once the dipole align the field, then it will be in stable configuration. Again I am telling, a dipole placed in electric field, uniform electric field, two forces acting at different points on the dipole, as a result a torque will be produced, and to calculate the torque, any force you take and perpendicular distance between the two lines, you draw x. Now x by 12 is sin theta. If you put here, then we get 2 vector sin theta. So torque is the vector quantity P cross A. Now right hand thumb rule you apply to find the direction of torque. So this equal and opposite forces acting, so net force on the dipole uniform field is 0. As a result, no force is acting on the dipole. Forces are balanced. As a result, no linear accelerated motion, no accelerated linear motion. For dipole, net force 0, but there is a torque. Torque will align the dipole along the field. So this is very important. Once the dipole align the field, angle theta will be 0. At that moment, dipole torque for dipole will be 0. Now, when you are displacing the dipole against the torque, what will happen? Let us see. Now calculation of potential energy, for dipole, calculation of potential energy. Now there is a dipole plus Q E minus Q E. Now question is, if the dipole is placed in non-uniform field, then what will happen? Net force not equal to 0. In that case, what will happen? If net force is not equal to 0, then two motion you will observe. One is the linear motion accelerated due to resultant force, and another force is torque for it to rotate. So rotational motion and the linear motion, rectilinear motion, both you will observe. Now you see the angular displacement against the torque equal to d theta. So work done dW equal to torque into d theta. If you put Pe sin theta into d theta, now net work done, that is the potential energy, minus Pe integrate theta 1 to theta 2 sin theta d theta. So it is coming minus Pe cos theta 1 to theta 2. So you are getting minus Pe cos theta 2 minus cos theta 1. Now consider theta 2 equal to theta, initial point of theta 1 equal to 90 degree. When the torque is maximum, you are getting potential energy equal to minus P dot E. Now U is maximum, U is minimum, that is minus Pe. It is net questions, very important. U maximum when plus Pe. Potential energy maximum when the dipole placed at the reverse direction of the field. Again I am telling, a dipole in the placed, suppose a dipole is placed in this theta. Now dipole is replaced d theta against the torque. So negative work is done, P sin theta d theta. So sin theta d theta equal to minus cos theta, minus is coming outside. So upper limit theta 2 and lower limit theta 1. So you are getting minus P cos theta 2 minus cos theta 1. This work done stored as the potential energy. So we have potential energy U equal to minus P cos theta. Now minus P cos theta means minus P dot E. So that is the potential energy formula for dipole in electric field. Now this potential energy minimum when the dipole align along the direction of field, that is a stable configuration. But once the dipole against the field, opposite to the field, there is unstable configuration, potential energy maximum, because you know any mechanical system when potential energy minimum, that is stability, and for maximum potential energy unstable. Thank you all. You wait for next class. This dipole portion will be completed, and this channel Sir Roy Physics will give trace on numericals for that above mentioned exam. So you cooperate with me. If you think that my channel is very helpful to you, or it is helping little bit for your any competitive exam, you all children, those are dearest to me, please subscribe my channel and you suggest me what I can do for you, so that your future will be bright, in near future will be very bright. Thank you all children.